So hi everyone. So this is coming back to the meetings. This one on a couple of new packages for Noel. So Noel, you probably know very well. Most of you, if not everybody, is an author, main author at root numpy, and he's come now with two other packages that link important packages in HEP to numpy. So I think you have presentation for both packages, right, Noel? And you will be sharing your slides?
Great. Yes, my slides are shared, I think.
Okay, yeah, you can see that. All right, thanks. So I think you can get started.
All right, cool. I'll put this in full screen here. There we go. All right. So I'll just very quickly introduce you to numpythia and pyjet, two side projects that kind of grew out of another research project. If you have any questions or anything, just interrupt me whenever. That's no problem. So the purpose of these two packages is to interface Pythia and pyjet with numpy, and therefore interface with basically the rest of the scientific Python ecosystem. Yeah, so why? Kind of reiterating that, but more specifically, why did I implement these? Well, we had this project here where we were applying deep learning on jets, and I needed some convenient way to generate events and cluster jets within a Python-based machine learning pipeline. And I wanted it, what I mean by convenient is within the same software stack and framework, so that I could easily generate events and cluster jets on the fly without having to go through some intermediate format like root or FMC files or what have you. So it's all basically natively in NumPy. And on the deep learning end of things, we had Keras and TensorFlow and all of this. How? So I'm not going to go into the details here, but you can certainly go look at the code on GitHub. But it's basically using Python. So Python is essentially a static Python compiler. It's somewhat of an in-between language between Python and C++ or C, but it compiles. It has a compiler that compiles this in-between language to C++ or C, or it'll just compile straight Python code to C++ or C. But it's also a very convenient language to write an interface with some extension library. So essentially what you do is you create a bunch of interface files that tells Python what classes and methods on these classes are available in your C++ library, and then you can write code that interfaces directly with this. One being NumPy, and another being, say, Pythia, fastjet. Because don't forget, on the back end, NumPy is a bunch of C code. So interfacing Pythia with NumPy. You can pip install this. It's been available now for a few months. Well, really since back in June, let's say. It only depends on NumPy. The package contains the full source of Pythia 8 and HEP 3. So it's the latest version of HEP where they've introduced a few interesting filters, particle level filters, which make it really convenient to use. So so when you pip install numpythia, it's downloading essentially a 6 megabyte tar.gz, so pretty small, and then it has to compile Pythia and HEP plus the interface from source. And typically, distutils does this in series. But I've kind of monkey patched it so that it runs the compilation in parallel, kind of just like a make-j. So after that, we have numpythia. You can import pythia and a few other interesting things. And then basically you have this pythia object. You can set its random state. You can give it some text file, give it a configuration file that configures what event will be generated. And when you're iterating over events on this pythia object, you can select only certain particles to be converted into a NumPy array. And what we're doing here is we have a selection looking for final state visible particles. And this array has a data type of energy, px, py, pz, and mass, plus a few other things that's needed by, say, Delphi's for reconstruction in a detector. And that's really it. It's that simple. This is probably the easiest way to install pythia. And just pip install it. So moving on. All right. So we have pyjet. In this case, we're interfacing NumPy with fastjet. And any of you who have used fastjet before, you know you have this FJ core release, a very minimal release of fastjet that has all the essential functionality. And that's essentially what's going on here. In pyjet, I've embedded that source, and and it compiles it. It compiles the interface as you pip install it. So here's just some example code from pyjet. You just import the cluster function, and this function is the generic clustering. It can be anti-KT, KT, Cambridge-Aachen, and you feed it an input NumPy array. So in this case, it's just vectors, and I'm grabbing a sample event from pyjet to cluster. It can handle both array of vectors in PT8FI mass convention, or you can use energy px, py, pz, as is the case if you're feeding in, say, particles from pythia or numpythia. And just below here, you see a complete, well, an example taken straight from the repository itself, showing you the difference between anti-KT, Cambridge-Aachen, and KT, you know, the famous jet area plots that you see from the original anti-KT papers. And that's all. Those are created with pyjet and matplotlib. All right. So next slide. Putting them together, just a minimal working example. So of course you can have numpythia generate particles on the fly, and then you can cluster them with pyjet. And here's just an example where I'm selecting visible final state particles. I've configured pythia just to turn on all RQCD. I set the beam center of mass energy, and then I've put a cut on the phase space, just so I get a bunch of interesting events where I have, say, a jet with at least 100 GeV. And it's really that simple. And it's fast, because on the back end, of course, it's compiled pythia and it's compiled fastjet. All right, so you can even, on the next slide here, you can use, say, root numpy to grab some of the public CMS data on EOS public, and then you can run jet clustering on that. Say, if you wanted to try a different jet radius parameter, if you're doing some studies on say, wide jets, but you wanted to use some real data, real public data, you could do this. And essentially you get the same jets that CMS gets, but you're doing the clustering yourself. All right, so just 2 more slides and then I'm done here. So it's been on GitHub since, let's say, April or May. Now it's under scikit-HEP, but it has some good reception within the community, and actually we've had 1 pull request in pyjet where someone has come along and actually they also needed this package to do some deep neural network training, but they needed access to the jet clustering history, so that was implemented. So a fair amount of the basic pseudo-jet API in FastJet is wrapped and accessible within pyjet, but not so much of the more advanced, like from FastJet contrib or nsubjettiness. These kinds of things are not wrapped, but could easily be included if needed. Yeah, and then I'll just end on this one last slide. What others are saying. Just, someone sent me an email saying that this was the pyjet package it turned out to be very useful for them. This is just so lightweight, just a pip install it, so easy. You don't need to spin up any C++ compiler yourself or interface it with some Python library through some obscure intermediate format. Just pip install it, so it saves them a lot of time to implement a quick study. Yeah, so that's very quickly overview of numpythia and pyjet.
Thanks very much, Noel. I will have a couple of questions, but maybe we should start by anybody outside wants to have a suggestion or a generic question to Noel, please. It was a short and sweet presentation, right? So probably have some questions. It's easy.
No question from me. It looks lovely.
It looks very simple, which is
Thanks,
always Noel, I have a question that they come up to me while you were presenting the examples. Is on numpythia itself. Now, imagine I have some configuration of pythia for HEP, which is for sure different from the ones from Atlas and CMS. Is that easy to have some special configurations or experiment-specific configurations used rather than just one standard pythia, or not?
Yes. So you'd like to install numpythia against a specific version of Pythia that you already have locally?
Probably, yeah. I'm pretty sure there's the version. Yeah, I can't remember the version, but yeah, you imagine you have some configurations because the settings are not quite the same for the experiments. So
yeah. So that's already possible with pyjet to install with an external FastJet. So you can just pip install with external FastJet as an installation argument. But that's not currently possible with numpythia, but it could easily be added. It's just basically at pip install time, it would look at a specific path on your file system instead of within the package for the Pythia source.
Okay. Yeah, that could be interesting for a larger community, right? If you go beyond that as a
Yeah,
and
for sure.
For explanation, I actually advertised the meeting to folks in our exotic QE, which is basically QCD, jet-like electric, and so on. So you could have customers there, and they will probably have to use some specific configuration to LGBs. That's why it came to my mind now. So that
Yeah,
could be
exactly.
useful. One thing, have it for both packages.
I guess I'll mention one thing here is with HEP-MC3, there's one tricky part that I had to overcome in that, see the selection here that defines some Boolean expression. to select particles that end up in your record array. These are actual objects. So status is an object and has-in vertex is an object. These are objects within HEP-MC. And the issue is that because HEP-MC is a C++ library and how it's constructed, it actually determines whether or not this is a valid selection at compile time. And that's, of course, something we cannot do in Python. Like, this has to be validated at runtime. So I had to kind of tweak the HEP-MC source a little bit to give me the flexibility to define anything I wanted at runtime, but then do the validation. Is this a valid selection at runtime? So anyway, but the syntax is basically identical to how you'd write it in C++, which would then get validated at compile time.
So hello, can you hear me?
Yes.
Yeah, this is Carlos. Yeah, from LCB. As Eduardo said, he sent email to our working group, QE Exotica, and through QCD, and yeah, I just connected. Thanks, Eduardo. And yeah, I have to say that I tried the pyjet because this is very useful for us. For example, to run to prepare some prospect. We are preparing studies for prospects for the high Lumi LAC state, and we are basically using the tools, and we discovered by chance pyjet the other day, and it's amazing. And I think yeah, this I didn't know about this numpythia, but I think would be quite interesting, at least for us, for people that are not used to use Pythia directly, but this kind of integrating projects we have at LCB, and I think this would be great. I think yeah, we should announce it a bit more at the different working groups at LCB, not only at this QCD Exotica group.
Well, yeah, that's good to hear. Thank you.
Yeah, I'm very glad that that was successful in that email. Okay, cool. Okay, thanks, Carlos, for joining in any case. I don't know if there are any more questions or comments to Noel at this stage from our side. We don't see who else is connected, so it's a bit difficult to people. No, it's okay. Yeah, I think it's usually many more people outside than the inside.
So Noel, what considerations are there for trying to include this into like a larger experiment stack? I mean, are there, for example, if we wanted to get this shipped with CMS, is there binary ABI compatibility issues, or I mean, what should we watch out for?
All right. Well, I guess one is the license being, well, in fact, it's not really my issue, but with PyJet, like I have to use their license because it's GPL. So there's that, but that's already been an issue anyway. But then, because the binary gets compiled and it's really only I think it's sufficiently like sandboxed within the package itself that it's not going to interfere with anything elsewhere. But that's something to be seen.
Noel, this is Michel. Jouvin, about the license of pyjet, you probably know, if you look at their license, that not only they are GPL, but they are GPL v2. I don't know if you are aware that there is some discussion with the pyjet people that they move to GPL v3 because GPL v3 and v2 are incompatible, and it's basically a mess. So at some point, I think you should be able to release it at GPL v3, as GPL v3 at least.
Okay, that's good. Yeah.
Because there is no way for the rest of the software stack to be GPL v2 anyway. So it's really the discussion is going on, but we hope to be able to conclude something with them in the near future.
Okay.
Okay. Anything else? this stage? If not, we can let Noel sleep again, because I think it's very late.
Thank you.
Okay, so thanks very much.
Yeah, I did actually go to sleep, and then I woke up for this talk, and I'll go back to sleep.
Very wise, very wise. Okay, thanks everyone, and particularly Noel for joining and giving the presentation. So, yeah, see you next time then. Bye-bye.
Thank you.
Bye.
Out.